Okay, yesterday we started factoring polynomials of higher degree and we learned some strategies there. We're going to learn another strategy and it involves the factor theorem. The factor theorem states that a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. So for example, we're going to determine whether the given binomial is a factor. Okay, if it is a factor, we're going to see if f of whatever equals 0. So to determine whether x minus 2 is a factor of f of x, we need to figure out if f of 2 is equal to 0. Okay, now to evaluate f of 2, we can plug 2 in directly, or we can use synthetic division. It's whichever one looks easier. Okay, in this case, plugging in 2 into this polynomial looks pretty easy. So let's go ahead and just plug it in directly. So if I do f of 2, I'm trying to see if it equals to 0. So that's 4 plus 6 minus 4, which is 6, which does not equal to 0. Okay, so what's the question asking? Is x minus 2 a factor? Okay, x minus 2 is not a factor because f of 2 does not equal to 0. I don't need to say what it equals to. I already showed above that it's not equal to 0. Okay, let's look at B. B is asking, is x plus 5 a factor of f of x? Okay, if it's x plus 5, then that would be when x equals negative 5. So I want to see if f of negative 5 is equal to 0. Now, if I want to plug negative 5 in here, I'm going to have to do negative 5 to the 4th, and I really don't want to. So to evaluate f of negative 5, I'm going to do synthetic, and that's because it looks easier in this particular case. Okay, let me put the coefficients. So 3x to the 4th, 15x to the 3rd, minus 1x squared. Oh, there's no x term, so don't forget to put your 0, and then the 25. And I definitely would not have wanted to plug that in. Okay, let me bring down the 3. See, negative 5 times 3 is negative 15. 15 minus 15 is 0. Negative 5 times 0 is 0. Negative 1 plus 0, negative 1. Negative 5 times negative 1 is positive 5. 0 plus 5 is 5. Negative 5 times 5, negative 25. Okay, so that gives me a remainder of 0, which tells me that f of negative 5 is equal to 0. So the question says, is x plus 5 a factor of f of x? Okay, x plus 5 is a factor because f of negative 5 is equal to 0. And that's what the factor theorem tells us. Okay, go ahead, pause the video, try C and D on your own, and then unpause when you're ready to check your answers or when you're ready for the next example. Okay, for C and D, I found that both of the binomials were factors because when I evaluated it, I found that f of the number was equal to 0. And if you did direct substitution, the first one wouldn't have been bad, but the second one you probably would not have wanted to do that. Okay, now we're learning the factor theorem to factor higher degree polynomials. Okay, so this is going to be to show you how we're going to end up factoring higher degree polynomials, and they're going to tell you one of the factors. Okay, so this says show that x plus 3 is a factor of this polynomial, and then we're going to factor completely. Now, in the last section, if we saw something like this, we would factor by grouping. Okay, let me show you what happens when I factor by grouping. Don't copy this. Okay, I would get x squared, x minus 3, minus, what's the common factor here? Minus 2, 5x minus 6. Okay, since these do not match, there's no common factor and grouping will not work. So this is the method we're going to use when grouping fails. Okay, so the first thing says show that x plus 3 is a factor of this function. Okay, so I'm going to plug in x equals negative 3. I'm going to do synthetic because I think it's faster when the polynomial is of this degree. So let's see, 1x cubed, negative 3x squared, negative 10, and 24. Bring down my 1. 1 times negative 3, negative 3, negative 3 plus negative 6, negative 3 times negative 6, positive 18, 8, negative 24, and 0. So x plus 3 is a factor because f of negative 3 is 0, or we had a remainder of 0. Okay, I'm going to write the polynomial that is left over so that we can then see how we're going to factor this completely. Okay, the remainder is 0. This is constant. This is x squared. So this is really x squared minus 6x plus 8. Let's go back to the original polynomial. Okay, f of x equals. Okay, now I know when I divide by this, I end up with this, which means this times this is equal to this. Okay, now it's asking me to factor completely, so I'm going to keep going a little bit more. If I can factor that trinomial, I will. Okay, x squared minus 6x minus, what is that? X minus 4 and x minus 2. Okay, so now this is factored completely. I factored it all the way into linear factor. So this one is called factor completely. And this is why the factor theorem is useful. So we can factor things that do not work by grouping completely. Okay, you're going to go ahead and try the ones on the next page. When you finish, check your answers on the calendar.